in general, the majority of developer concentration still exists on Ethereum. And I think that comes down to the fact that users are king. So I think Solana's had a great come up recently in speculative activity, but in general, users gravitate toward wherever the most activity already exists. That's not to say how things will progress over the next couple of years, and I'm not going to make a prediction either way, but in our experience, that's generally what we found.
Yeah, I think when I started, the developer tools were so bad that you couldn't call them existent. It was like, yeah, you read the code and figure it out yourself. I think Ethereum has like done a really great job at making everything easy. And like, especially if you're like a new developer in the space, you'll have a way easier time going. But then it's like about, if you want to create something that is really cutting edge, you'll hit a lot of roadblocks. You'll be like slowed down and you'll have to redesign your application like lots of different ways and like cut it down because it just certain things can't be solved stupidly or naively. There's something I feel is like very special. And so that creates this like drive for the people who are daring to get past the initial hurdle to like do stuff very quickly, try it out, throw it out, which I don't see in Ethereum side. People sometimes take 2 years to write a smart contract and then deploy it immutable. And it's like, yeah, you had the idea 2 years ago. Is it still valid? Is it still contemporary? Is it still something that people need?
So I actually have a hot take here, hopefully something that's maybe novel, which is basically that blockchain applications, the whole premise of it is leveraging shared global state. So it's really the state that matters. The compute is not actually like the big bottleneck or the thing where there's a lot of work. The thing that's expensive is accessing the state that allows that computation overall to proceed. So the actual, like when we talk about EVM versus SVM, and I'm not sure that that's actually what is this debate EVM versus SVM or is Solana versus Ethereum? I don't know. It's hard to untangle those, but actually like when you're building an application, like forget about blockchain for a second. If you were deciding, should I build this in Python or should I build it in C++? You would be debating like, C++ is a lot more efficient, blah, blah, blah. I'm going to need to invert all these matrices. It's way faster to do that in C++, blah, blah, blah. That's always about computation. And so it's understandable that people would pick like C++ if they had something that involved a lot of computation. Maybe Python if they want to do something more flexible, something easier to read. But in blockchain, it's actually not the computation that matters, it's state access. So I think fundamentally the whole debate between EVM and SVM is sort of a transient state right now where because EVM state access is not very efficient, we sort of conflate that with the EVM itself not being efficient, which I actually don't agree with. I think the bytecode standard itself is actually totally fine. It's just the state access that needs to be improved.
My take's not as hot or controversial, but I think, still equally valid maybe. I don't know. But I think another thing is also resiliency and redundancy, right? I think that, at least right now, right, is with the emergence of SVM, and I know Neel over at Eclipse, you guys having that as a RAS service offering, which is pretty incredible. And I think that that's an amazing step towards redundancy and resiliency for the Solana ecosystem, right? With Ethereum on the EVM side, right? Like, let's say, for example, one day Ethereum implodes and nothing works, right? And then all the other L2s don't work. Well, there's also a bunch of forks of Ethereum that are also EVM compatible as well, right? And so as an application developer, you also have that sort of fallback option, right? You don't have to rewrite the code and, think about all the sort of resiliency moving forward from there. And so I think that that's definitely also a benefit. And even, I guess, further from that is, I think you had mentioned it as part of the question, one of the factors for Solana is cost. I think it definitely is very attractive, right? Like, but at the same time, right, I think like despite how slow Ethereum moves, right, there is, I hate to say it, but, proto-dank sharding and Dankun, right? And proto-dank sharding obviously is just sort of the first step in that, right? And, full dank sharding, hopefully sometime in the future, not after 3 years or something. But, I think those types of efforts also are trending towards kind of reducing the cost significantly, right? And even alternatively, we see, modular solutions, modular DA solutions, right, popping up. Celestia, then there's EigenLayer coming out, and then there's a Veil and all that stuff. And I think that these sort of modular DA solutions are also kind of attributing a lot of benefits to the overall cost for even EVM environments. So yeah.
So Keone, just to rephrase your portability point, you're saying that because there are other EVM chains, if your app is deployed to an ecosystem and that ecosystem implodes or something, then you would deploy to another one.
Yeah, and it's not a perfect solution, right? It's not like your TVL magically appears on the other chain, and it's not like your users magically appear on the other chain as well. But like from like a cold start perspective, right? At least you can start hitting, or you can hit the ground running on day one again, right? Rather than having to refactor the code.
I've just pretty much found that that's never played out in practice. Like, so a couple of years ago, I used to build an EVM bytecode interpreter on Terra, and the reasoning was largely idiosyncratic to Terra. Terra itself was performing extremely well. There's a ton of TVL growing on there because of Anchor. And when Terra depegged, I could have taken that same EVM bytecode interpreter and deployed it to pretty much any Cosmos chain. But at that point, as a builder, I had to take a step back and think, what's my opportunity cost? And should I retain my code, or is that just me coping, and do I need to just go back to the drawing board? Ultimately, I did the latter, and I think that a lot of builders end up having the same experience when these ecosystems do end up imploding.
Sort of extension to maybe what you were just talking about, Neel. Do you think like bytecode encoders or I guess more broadly like transpilers get to a point at some point in the future where it doesn't necessarily matter if you're writing in like Solidity or Rust or SVM or EVM, and you'd be able to shift between them? And this is an open question to anyone if we think the tech can get there.
So I actually think Keone is going to have a better take on that than me, but at least to my understanding, like not every language can compile to every bytecode. And just because like the execution model of the SVM, for example, there's attempts like Solane to get Solidity to compile it to SVM. Ultimately, the Solane project was discontinued. And even writing Solane required a lot of changes to traditional Solidity code as it was written for EVM chains. So you have to mention what your state access is. You have to mention a bunch of additional meta information because that's exactly what the SVM requires to enable its parallelism. But Keone might have more detailed understanding.
Yeah, I think that's accurate. I mean, there's a lot of differences right now between Ethereum and Solana in terms of how transaction data is presented. Over time, we could see convergence in that realm. Like maybe Solana will not have pre-specification of dependencies, and maybe like, yeah, I don't know. It's just, maybe the scheduling algorithm that exists in Solana is adjusted or removed, and parallelism is done optimistically. Or there's just I think ultimately there actually will be kind of a convergence in terms of the kinds of behaviors, which would make a transpiler easier, but it's not in the next 2 years. Like it's still pretty far away. Other priorities dominate.
This is a more broad question, but yeah, kind of like given the rapid pace of innovation and competition in the blockchain space, which platform do you think is better positioned for long-term viability and adoption, Ethereum or Solana? I guess I'll modify this question slightly. You could say neither if you want.
I see why you had to put that caveat at the front of this.
We could also skip this question.
No, we can't skip it now. I'm just saying I understand.
I think what's good about the ecosystems is they have such different North Stars, where Solana is optimizing largely on performance at this point. So that means that I don't think fraud proofs or data availability sampling or other forms of verifiability are likely to be adopted by Solana in the near to medium term, if maybe not even in the long term, just because those things they impact performance to some degree. Whereas Ethereum has that hard constraint of verifiability via L2s, and of course L2s in their current state are not fully verifiable, and they don't fully inherit all the security properties of Ethereum, but at least in the end game they will. So I think it depends on the user and the type of application, but I could see a world where both of them coexist.
I think most teams that get really, really serious in building applications are kind of at some point going to leave the L1 unless there's a real reason for them to be there. I think if you have, we've seen this like transition maybe with DYDX the best, right? They were really early on EVM, then did an L2, then decide, okay, let's build an app chain. We see this also with MakerDAO. We're like, yeah, skip the L2s. Let's just straight up build an app chain. There's just like kind of like this extractive overlord mechanic in the L1 that a lot of builders that build dApps at a high scale out will perceive as overpaying, right? So the idea that you pay like a constant tax that is kind of like driven up by all the other noisy neighbors on this chain is just like a little bit insane. And I think no one has solved that, neither Solana nor Ethereum. So until someone hits that nail really hard in and like manages to present a solution of an L1 that doesn't suffer from it in terms of like block constraints and scheduling. Maybe the proto-dank sharding roadmap and like the full dank sharding roadmap is the way there, but I'm deeply skeptical that will allow a fully, scalable solution that it just allows multiple application developers to feel they're not intertwined, right? And that's not even touching on, it's just performance. It's not touching on like, hey, we want to stop the chain rollbacks and transactions because there was a big hack, right? Which is also a requirement by now for some applications. They just want to be able to be like, yeah, this is a user-activated soft fork. That's like one of the main reasons why MakerDAO says we're going to build our own L1. They want to be able to do that with governance, and they can't on Ethereum.
Yeah, that's a good point with MakerDAO, because they do want to be able to control their own destiny with respect to a hack. But I think that I kind of disagree on the more general question of the most successful apps all becoming app chain / rollups, because I think it's really hard as a very app branded rollup to then convince other apps to migrate in a significant way, or at least to get use. I mean, it's easy to like deploy the apps, but it's hard to get like usage of that. Like if every app developer has their own chain, it's almost like nobody has their own chain. It's really just really hard. I feel like the brand is really, and so to your point about the extractive nature of Ethereum in particular, like Uniswap team is very like annoyed at the fact that there's like so much value that Uniswap has created, but all of the, users pay really high fees, but it all basically just ends up going to the validators. And we just have like high yield for stakers or a lot of burn, $3 billion a year of fees paid to Ethereum. That's like also just driven by the very limited block space. It's like insanely limited, 1 million transactions per day. Like in a world where you 100x that or 1000x that, like you don't have that insane like surge pricing that, then results in the L1 getting a lot of burn or a lot of fees, but the app's not getting anything. And it could be that the app has a business model where the app can't actually charge. I mean, they turn on the fee switch, or it looks like they're going to turn on the fee switch soon. Like I see why you have that disclaimer in there again. Like there could actually be models where the app is able to like capture value.
I mean, even like Solana has 1 billion transactions a day. That's also not enough. I mean, we're able to hit that. Like if you have a really successful app, you'll hit it. I mean, what's the limit, right, that you can sequence?
I think Solana is like 100 million per day right now. Solana is like 100 million per day right now. It's like 1,000 per second times 86,400 seconds.
I think the point is like, regardless if it's 100 million or a billion or whatever the number, right? You're just kind of moving the goalpost.
Oh yeah. No, well, you need density in the, like Solana is actually like pretty dense in terms of compute. So then like if we saturate Solana, launch Solana 2, Solana 3, like the partitions, but scale horizontally, but at least like have each of those partitions be sufficiently dense.
Yeah, I think the scaling horizontally point makes a lot of sense. And I think we're at a point now where like we're starting to realize like, L1 scalability is not there, obviously, right? I couldn't have seen that when Ethereum first came out. And then now we're kind of seeing L2 scalability, at least vertical, is not necessarily enough, especially not for a killer app, right? Like it's nowhere near the scalability that we already see on Solana. And then so I think like horizontal scalability is definitely the way to go. And I do see a lot of focusing more on like even proof aggregation for ZK proofs and kind of like conglomerating those L2s for that more horizontal scalability future. But yeah, I mean, like I think at the end of the day, both Ethereum and Solana can exist as, the settlement layer, but I agree, like applications shouldn't be running on the L1 in the future. Yeah.
I think settlement layer is like there's like economic security. It's like one of those nothing burger arguments people like cling to as a last straw.
So you think the L1 is just entirely like
No, I just think people are gonna figure out their way around it. It's really good to start. Like if you want to start a network, try like a decentralized application. You don't need to care about provisioning nodes, keeping them running, having like no single point of failure in your community, right? Like bootstrapping that community and the people work together. It's like a whole lot of work, right? Even if your application is very focused, it's gonna be just the ops overhead is gonna be intense, right? And similar to how you see people start in AWS, it's great, but eventually the fee's gonna be too high. Like, people like Basecamp or whatever, right? Like people move off the cloud. They're just like, oh yeah, let's get a bunch of data centers. Let's do everything in-house. It's not difficult, right? And if you save 10x the cost, why not?
But I think if you're thinking about like the cloud analogy here with like Basecamp, right? Like, do you feel like there's, Basecamp represents the 99% of applications, or do you think Basecamp represents like the 2% of applications?
The very profitable ones, yeah. Like as in like 99% die and one survives, yeah, exactly that.
Sure, but I mean, like in that case, right? Despite not being a Basecamp, right? If you're like a Duolingo, right? Like it's still a very large consumer-based application that is fully on the cloud, right? So I do think, like, I agree, like, there are situations where, these types of infrastructure doesn't make sense when you scale large enough. Have that ability to actually kind of build out all those other components. But on the other hand, right, like for the vast majority of applications, right, like you still at the end of the day, I don't know, maybe with AI it'll change, but you still at the end of the day an application developer, right? Do you really want to worry about the DevOps, which, all this and then all this other stuff?
Wait, Max, so when you think about starting your own app chain as an application and you think about value capture, is that more about MEV recapture, or is it about straight transaction fees that are being paid to some other L2 or L1?
I think you have like mission critical types of transactions, and any kind of mission critical transaction will create a huge surplus to stakers, because now it needs to compete with everyone else. Most transactions are not super mission critical. They can go slower, priority. There will always be like one few things that you really need to make sure that happen. And those things, like if your application has those, then you're just going to pay a lot. Like there's no...
Yeah, you could theoretically build in an auction mechanism or something to accrue the surplus in a different way, but then you're incurring latency and there's some downside in some way, shape, or form. Yeah.
Speaking of mission critical application, it's kind of a good segue into this next question. There's 100% guaranteed, I guess historically 100% guaranteed inclusion on ETH L1, like in the sense that you can always pay something to get something through. Matter for, mission critical applications deploying there versus like somewhere on Solana or potentially a newer, less, Lindy L1 where, it's like 99% of the time. But of course there might be a couple hours where things might not be propagating, and it could be catastrophic for certain use cases. How important is like that 99.9% versus 100%?
Well, L2s have outages too, right? But I think the difference is that a part of the security model of an L2 is this feature of forced inclusion. So for folks in the audience who might not know, theoretically, in the final form of a layer 2 network, you should be able to submit a transaction directly to the Ethereum layer 1. In the worst case, you wouldn't want to because it's more expensive, obviously, but you could update the state of the L2 chain, even if the sequencer goes down or if it's actively censoring your transactions. So this means that in the case that sequencers do go down, in the worst catastrophic case, if you have $1 billion in this L2, then you could theoretically exit and get it out. And I think that feature is definitely critical for institutions. And we saw what happened with Solana back a couple of years ago when there were billions of dollars on chain and the first outage happened. And that does damage trust from institutions that are trading a lot of volume on the chain. At the same time, like L2s in their current form have not solved that. Forced inclusion is essentially an unusable feature as it exists today.
So I think the Solana outages are actually mostly just driven by a pace of rollout of features and like a pace of innovation that is rather aggressive. And I think the Solana team has learned from some of the outages, like better practices with respect to like rolling stuff out on DevNet and TestNet and like these procedures that can help but fundamentally it is just like the substrate is changing much faster than Ethereum is. Ethereum has had some outages as well. It's just we don't really acknowledge them as outages because it's just a finality outage rather than a block production outage. But it's not something inherent to like Solana versus Ethereum. I mean, it is something different with respect to like the engineering orgs, and maybe you could comment on this as well. But like their philosophy on like how much stuff needs to get down and how fast to ship it. But I think it's not inherent to Ethereum versus Solana.
Actually, there is one argument there. There is an inherent difference because of the finality window. Like a block, you cannot continue producing blocks if you can't finalize. And so that's different on Ethereum. Ethereum can produce blocks while not finalizing, but Solana prefers that things are finalized over producing blocks. And it's just like, like cap theorem, kind of like you choose one over the other situation, where the basic design kind of leads to outages eventually.
Yeah, that's one part of it. I also feel that there's the truth to Keone's part is the last couple outages, like durable nonces, caused an outage. The recent one was just like something was already fixed in the latest Brit release, but they just didn't roll that out in production. So those are DevOps issues. But some of the historical ones, like all the outages that led to the QoS improvements, that was all related to Gulfstream and just inherent architectural features of Solana. And it was their first time experiencing that kind of influx of NFT mints. So there's not really a way to test that or to incorporate that into a DevOps procedure, in my opinion. It's just something that has to be discovered in practice. And it's because Solana is such an innovative architecture that they're going to experience issues that they're not really testable in my view.
I think just kind of going back to the nines, right? Like the answer right now, I think, is not as much, but I think inevitably the answer is going to be yes, right? I don't think, like going back to sort of cloud computing, I don't think you see any cloud computing service that can only guarantee like 1 9 SLA of service, right? I mean, these are like triple, quadruple nines, and even those have significant business impact, but we're just not at the scale there yet. Yeah.
We sometimes joke it's minus 1 9.
Sort of shifting gears ever so slightly here. What are the key metrics? Maybe, don't go crazy here, maybe like top 3-ish that you consider when evaluating how decentralized an L1 is, and how would you, rank those in the context of Ethereum versus Solana? Like the most important ones, let's say.
For me, it would be number of nodes participating in consensus, the cost of running a full node, and the full geographic distribution of stake weight.
All right, for me, it's unfortunately not, like the correct measures of decentralization to me aren't actually quantifiable. So it'd be, what's the attack factor that you would use to cause a safety or liveness outage in this specific blockchain? So like that might involve literally like sending a military with guns to like Coinbase and being like, shut down your validator. That could be a theoretical attack factor. And you'd have to think about what are all the attack vectors for the given architecture that you're dealing with. And then I think we're trying to essentially quantify that with these approximations like number of full nodes. But the reality is like I could be running 100 full nodes in my one home, and that's not really any more decentralized. So that's why I don't really like those measures.
Well, that's why I said geographic.
Geographic, yeah, that's fair. But even like 100 full node, I guess it depends on the granularity of the geographic distribution. If you get all the way down to like the exact longitude, latitude, then of course you'd want it to be like evenly distributed throughout the entire globe. But generally people are looking at like how many nodes run in each country. And it's not at that level of granularity where you'd be able to distinguish 2 people versus 1.
I see. Yeah. I mean, I've seen an erosion in the landscape of decentralization and what people are okay with. It's like really bad if all of the nodes are like in, all in Germany or something.
Yeah, agreed. Yeah, that's like table stakes.
So yeah, I'm protesting against what I think are very basic elements of decentralization, but then I just see like all this gaslighting of, like, oh, it's okay that they're all in Europe, whatever.
Please use Hetzner. The guys are great.
What was that?
Hetzner is the company in Germany that has like the cheapest data centers worldwide, and just everyone runs their nodes there.
But it's not because they're cheap that they run them there.
Yeah, they kick you off. Yeah, it's fun.
Max, what would you say? Or do you can agree too?
For me, like the question of like decentralization, right, is about like how complicated is it to change directions, I would say. Like what's like the level of influence you need to create in order to modify something on the network, right? In terms of like basic fundamental rules. And then I think right now on Ethereum, I don't know how you would measure that, right? But how difficult is it to get like Vitalik to blog about it, and then developers in the Ethereum Foundation to research it for a year, and then put that into like production, right? How difficult is it to get the Bitcoin people to like change something on mainnet, right? It's pretty hard, and have an impact, right, on the functionality of the network. I was out of a developer perspective, right? I feel there's on the Solana side, there's actually like a lot of effort to like change that, and get more teams involved. More people think about this as a possibility and actively influence how does consensus look like in a year from now.
Yeah, I think we're all just saying that like decentralization is a very vague term that, we all have some idea of what it should look like, but no sort of solid answers as to how to get there. But I think just one other fuzzy component to all of this, I think, is also around the human element, right? Like, how many developers are actually contributing to this ecosystem, and where are those developers located geographically even, right? Because that also can impact, the quote unquote decentralization of all of this. Yeah.
There should be like a Maslow's hierarchy of decentralization.
I sense a blog post. Anyways, I guess that leaves everyone something to think about there on decentralization. We're wrapping it up here. I'm told we're out of time, but thank you guys, all of you, for participating in the panel. Thank you, Seth.
Thank you.
Thank you.